In this lesson, we're going to look at direction notation and trigonometry.
Okay, hi everybody. So here we're going to take a look at just an application of trigonometry in the context of directions, okay? Planning a trip like hiking or something like that. Basically where you might give directions to somebody here. So to start off with here, we want to talk about what a bearing is, okay? So bearing is just a way of communicating a horizontal direction in degrees, okay? So there's a couple different ways that we do this, and so you just need to be familiar with both of them. One way, and the first way we're going to look at here, is to give an angle that's less than 90 degrees, but give it with respect to the 4 points on the compass here, okay? North, south, west, and east. And I'll show you how we do that. So to start off with the 3 examples that we're going to give you here, we might give the direction as north 40 degrees east. So the first direction here, the N, tells us where we start, and then we're going to rotate 40 degrees in the direction of east. So from here, we're going to rotate 40 degrees this way. And that would communicate a fairly clear direction that we might be going here. Or you might say west, 20 degrees south. So in other words, we start pointing in the direction of west, and we're going to rotate 20 degrees towards south. Okay, and that would tell us that we're going in this direction right here. Oh, there's a little bit of a mistake here. Northwest, if you ever see something that's northwest, like the two of them together here, or northeast, southeast, southwest, that means 45 degrees west of north, or 45 degrees north of west, right? Where both of these are going to be 45 degrees. Sorry, I should clean that up there. That was just a little typo. 45 degrees. So that's one way of doing it. Another way of doing it is to use 3-figure bearings, okay? And so when you see something like this, where you've got these square brackets here and you've got 3 digits, those digits all together give you the angle that you're going to rotate clockwise from north, okay? So a bearing of 035 is going to be 35 degrees clockwise of north. Okay, and so now I have a sense of where that is. If it's 110, okay, 110, okay, then that's going to be, oh, there's another little error there, 110 degrees clockwise from north. So starting there, we rotate this way. Over here, if it's a bearing of 270, okay, that's going to be 270 degrees, okay, again, clockwise, starting at north. And notice that that gives us a direction of west, okay? So that's how you would answer that here. So if you wanted north, north would be, for example, a bearing of, north would look like this. East would look like that. South would look like this. Okay? And we've already seen what west would look like. West would be 270. So anyway, just knowing that this is kind of how we communicate the angles here, let's take a look at some examples that utilize this, that give us the information in this form, but they are trigonometry questions. Okay, well, before we get into actual questions where we use trigonometry, we're just going to sketch a couple of these directions here. And bear in mind that another reason why this is important here is because when you start to work with vectors in mathematics, remember a vector is a magnitude with a direction. In a lot of cases, this is how they're going to communicate that direction. And there's other ways that we do this, but this is one of those methods here. So 325, okay, at an angle of 325, or a bearing of 325, means we're going to start at north, and we're going to rotate clockwise 325 degrees. Now, let's think about this. This is 90, 180, 270. So we're going to be somewhere here, okay? And, well, what are we here at? At 325, we are 35 degrees shy of a full rotation. So it's going to be out like this. Angle's going to come all the way around here, and this is going to be 35 degrees inside there. And so that's what we're being asked to do, to sketch the angle like that. For this second one here, we're going to go south, 17 degrees east. Now, I like these ones here. These ones are really straightforward. South, we're going to rotate 17 degrees in the direction of east, so that's going to look something like this, where this is 17 degrees. Okay, west, 40 degrees towards north, is going to put us up here. Not quite at the 45-degree mark, so just kind of in there, but 40 degrees towards the north here. There you go. Okay, that's how we would sketch those particular angles, or directions, I should say. Okay, so here we go with a problem that's going to require a little bit of trigonometry. So suppose you choose a starting point and then walk 350 meters in the direction of east 25 degrees south. Okay, so let's draw that out here a little bit. So here's our compass points, okay? So I'm going to go east 25 degrees south. Okay, so I'm going to go down. This is going to be 25 degrees. And I am going to go a distance of 350 meters. Okay, so let's just say that it goes to there. I just need a way to just kind of sketch this to get my head wrapped around what's going on. Then you proceed to walk 200 meters in the direction south. Okay, so here's where I stop, and I'm going to draw my compass points again. And I'm going to walk 200 meters in the direction south, 55 degrees west. So that's going to be out here. This is going to be 200 meters, and so it was south 55 degrees here. So this is where the 55 degrees goes, right there. Now, the question is, when you are done, how far are you from your original position? Okay, so I'm going to grab a pencil here. So what this is asking for is, what is that distance right there? And let's give it a, well, we'll call it x. Just for right now, we'll call that x. Okay, so, and then the question is, had you traveled directly from your starting point to your final position, what would the direction have been? Okay, I'm going to change the color here a little bit. So now, what I need to do here is figure out, well, what do I know? Okay, well, I know that if this is 25 degrees right here, well, I know that the west-east lines are going to be parallel to each other. So I know that if this is 25 degrees, I also know that this angle right here is going to be 25 degrees. I also know that if this is 55 degrees right here, that this angle inside here is going to be 35 degrees, right? Because these have to add up to 90. Now, put those together, and I've got a 60-degree angle inside there. Now, when you look at the information that you're given, it should be clear to you what it is that we're going to use here. Well, that's an example of the cosine law. So x is going to equal 350 squared plus 200 squared minus 2 times 350 times 200 multiplied by the cosine of the angle in between the two, 60 degrees here. And then remember, this would normally be cosine squared. So to get that answer, I'm going to take the square root of the whole thing. And actually, I can do that all in one step on my calculator. Okay, this will end up being, I want to make sure that we can see this all here, the square root of 350 squared plus 200 squared minus 2 times 350 multiplied by 200, multiplied by the cosine of the angle in between. Now we just want to make sure that we're in degree mode there, and we are. And so there we go. So now to the nearest meter, okay, to the nearest meter, that said that we were 304 meters away. Now, I'm being asked to do something else here. I want to figure out what angle we're going at. We're traveling along here. So although I'm going to say that that's 304 meters, I'm going to leave this answer here still in my calculator. That's the one I'm going to use here in just a moment. So now what I want to do is I want to figure out the direction that we would travel here. Now it looks to me, and I'm hoping that my diagram isn't too far off, but it looks to me that if I was to go directly from my starting point to my end point, that I would be going south some unit of measurement towards, or sorry, some little degree to the east here. Well, I'm not going to have the ability to figure out what that angle is, but I should be able to figure out what this angle is. Let's call that theta. Okay, should be able to figure that out. And I should be able to do that, figure that out using, well, I could do one of two things. I could use the sine law, okay, or I could use the cosine law. Okay, now, let's for example, let's just practice both here. Let's use the sine law. So I've got 304 over the sine of 60 degrees, okay, is going to equal 200 over the sine of theta. Now I'm not going to use 304. I'm going to use the number that's on the calculator here. But let's cross multiply here, because that's how we handle stuff like that. Okay, and then I'm going to divide by the 304. Now I know some of you are going to see there's a quicker way. I could have jumped to the solution here, but that's okay. I want to make sure that everybody follows what I'm doing here. So I just cross multiply and divide, and then I'm going to take the inverse sine of that expression. Now I'm going to go to my calculator and do that. Except here I'm going to use that 304, okay, 0.138, so on and so forth here. So this is going to be the inverse sine of 200 multiplied by the sine of 60, then divided by the answer that I just got in the previous step here. Okay, and I'm going to get to the nearest degree, 35 degrees. So that's going to be approximately 35 degrees here. Now, that's 35 degrees inside the triangle. Okay? When I put those together, if this is going to be 35 degrees and that's 25 degrees, well, that's an angle of 60 degrees. And you know what? I'm going to be a little bit lazy here. So starting on east, the direction east, if I rotate 60 degrees towards south, that's the direction I went. So the angle that I'm going to go here is going to be, starting at east, we're going to go 60 degrees towards south. That's the angle that you would have to travel at. Okay, we're going to take a look at another question. And actually this one is really quite similar to the one that we just did. But it says, suppose a ship captain has to alter his course, get around an iceberg. To communicate his final position to the port, he tells them that he traveled 30 kilometers on a bearing of 70 degrees. Okay, so let's take a quick look at what that would look like here. Okay, so let's draw our compass. Okay, so 30 degrees on a bearing of 70 degrees, meaning from 90, we're going to rotate over 70. So it's going to be something like this. And so this is going to be 30 kilometers. And this is going to be 70 degrees. Then we get to this point right here, and then he traveled 50 kilometers on a bearing of 95 degrees. Okay. And so 95 degrees is going to be something like this. It's going to be just a little bit more than east here. Actually, now I'm starting to regret putting that 30 kilometers right there. Okay. This is going to be down here like this, where this right here is going to be 5 degrees right inside here, and this is going to be 50. So this is 30 kilometers. Here's 50 kilometers, and we get to our end point right here. And then the question is, how far and on what bearing should the supply ship travel to get to that ship in the shortest time? So let's say from the starting point out to here, that's what we're looking for. Okay? So there's the distance x there. Okay. Well, now you just got to think, well, what does this tell us here? And actually, maybe what we'll do here is let's exaggerate this. We're going to draw this again, but we're going to exaggerate this a little bit. Okay, so now that we have an idea of what this sort of looks like, so I'm going to draw, again, the compass notation here, but I'm going to make this a little bit more dramatic. So we're going to go up like this, and then we're going to come down like that. And this isn't going to be anywhere near what that's supposed to look like, but it'll give us an ability to measure these angles a little bit better. So we know that this right here was 70. This is going to be 30 kilometers. This is going to be the 50 kilometers. And we know that this right here, this angle here is going to be 5 degrees because it was on a bearing of 0.95. So if this angle here is 70, because the north-south lines are parallel to each other, I know that this angle right here is going to be 70 degrees. Okay? Yeah, just because of the alternate interior angles of parallel lines. Now, if this is 5 degrees, then I know that right here, this is going to be 85 degrees inside here. So I'm going to use that to figure out what x is, the length of that opposite side in that triangle. So altogether, this is going to be 155 degrees. Well, now let's go to the cosine law. So x is going to equal 30 squared plus 50 squared minus 2 times 30 times 50 multiplied by the cosine of 155 degrees. And that'll all be square rooted. So let's pull out the calculator here. So square root 30 squared plus 50 squared minus 2 times 30 times 50 times the cosine of the angle in between, which will be 155 degrees. Okay, so we know that this is going to be approximately 78 kilometers. Okay, now I want to figure out what bearing this is on. So what we're going to do here is I want to figure out what this angle is right here. Now in the previous question that we did, I used the sine law here. But you don't have to use the sine law. This is actually set up really beautifully now to use the cosine law. So I'm going to figure out what theta is, and this will be the inverse cosine of, well, it's going to be that 78 squared, although I'm not going to use 78. I'm going to use what the calculator gave me, plus 30 squared minus 50 squared, and I'm subtracting the 50 squared because that's the side that's opposite the angle I'm looking for in the triangle, divided by 2 times 78 times 30. Okay, so now I'm going to go to the calculator here, and this will be the inverse cosine. Okay, brackets are on the numerator, so it'll be that answer that I just came up with squared plus 30 squared minus 50 squared. And I closed the brackets, but I opened up 2 of them here, so this is still inside the cosine, the inverse cosine function. Brackets for the denominators, 2 times that answer times 30, close, close. Oh, you can't see that. Oh my goodness. And I'm going to get, what is it, 16 degrees as a result here. So when I round that to the nearest degree, 16 degrees. But that's not the answer that we want. That is simply the angle between this line of motion and that final line directly from that point to the final end point of where the ship ended up here. So this is 16 degrees, but it had already traveled on an angle of 70 degrees. So therefore, its final bearing is going to be 0. I'm just going to add 16 to that, 0.86 degrees. Now, you can see that my diagram doesn't follow along with that. According to my diagram, that this should be altogether larger than 90. But I was just expanding that just so that we could kind of see or draw this out a little clearer. So I hope that makes sense. Okay, so in this question, we read that a ship observes a lighthouse in a direction of north 50 degrees west. Okay, so let's draw this out here. Now I got a little bit of room here I can play with. So here's our compass here. So here's our ship to start off with, and it notices the lighthouse here at north 50 degrees west. So it's going to be somewhere out here. And we're not told how far, by the way. All we're told here is that this is going to be 50 degrees. Then after sailing 36 kilometers in a direction south, 35 degrees west, okay, so it's doing something like this, and it's gone for 36 kilometers. 36 kilometers, whoops, below there. And south 35 degrees, so this is going to be 35 degrees right in here. The ship observes the lighthouse in a direction of north 15 degrees east. Okay, so the ship stops here and then looks towards the north here, or looks towards, whoops, oh, I'm sorry, looks towards the lighthouse and determines that that angle right there is going to be 15 degrees. Ah, that looks terrible. But anyway, you get the idea. So there's this line of sight from the ship where it is right now to the lighthouse, and that's going to be 15 degrees right here. So draw a sketch of the information. Okay, well, it's not a great drawing, but you get the idea. Calculate the distance of the ship from the lighthouse when the second observation is made here. So we want to know what this distance is right here, x. Okay, well, what have we got here? Well, we know that this angle up here, okay, if this is 50 degrees, then we know, and I'll use a different color here, we know that this angle inside here must be 40, okay, because those two have to add up to 90. And I could do the exact same thing down here. If this is 35 degrees, okay, then this angle up here must be 55 degrees. Again, so that those two angles add up to 90. Okay, well that gives me this angle right here, and so I've got x over that, which would be great if I had a side opposite an angle. But I don't know that angle. Okay, well I do know that this is 15 degrees. And what have I got here? Well, I know, okay, right here. I know that the two north-south lines are going to be parallel to each other. So if this is 35 degrees, I know that this angle in here is also 35. Now, the reason why that's significant is what I've got here is I've got this other line that goes through, and there's an angle of 15 degrees here. Now, if I take that 15 degrees away, okay, take that away here, that's going to leave me with 20 degrees right there. So the angle from the north to the ship out to its first position here, okay, that angle's got to be 35, and then that line of sight comes in 15 degrees. That leaves me with 20 there. Well, now I'm starting to make some headway here, because now I know that angle. So for me to get the angle that's left over in this triangle, I'm just going to subtract all the angles that I've got in there. And so I'm going to go, whoops, I'm going to take 180, I'm going to subtract the 40 and the 55 and the 20, and that is going to leave me with 65 degrees. Well, now I can use the sine law. So now I've got 36 kilometers over 6, whoops, sorry. I'm making a classic blunder with that. It's not over 65 degrees, it's over the sine of 65 degrees. Sine of 65 degrees, and that is going to equal x over the sine of, well, when I put those together, I'm going to get 95 degrees. Now in this case here, I could do the cross multiply and divide, but really all I got to do is multiply the entire equation through by that sine of 95, just to get rid of the denominator. So this will end up being 36 multiplied by the sine of 95 degrees divided by the sine of 65 degrees. And that should equal x. And so now that just becomes an easy couple of steps here on the calculator. So 36 multiplied by the sine of 95 divided by the sine of 65, and I get 39.6. Okay, so 39.6 kilometers away. That's the answer that we're looking for.